In question 72, we're looking, once again, shortest possible route. So that means we need to find a cos theta. Theta subtended at the centre of the planet. They're both in the eastern hemisphere, so there's around about 110 degrees difference. So we'll work the longitudinal difference, find theta, and then we can work through the distance, the time, and then the zone time on arrival. These all follow a very, very similar pattern. The only difference here is because they're both in the eastern hemisphere, I'm not going to bother with the circle diagram. So my longitudinal difference there. I'll now work through the cos theta formula. Now Melbourne is in the southern hemisphere, so it's negative, and Jerusalem is in the northern hemisphere, so that will be positive. Very important that you've got your positives and negatives correct in this situation. So theta is 123.43. Rule of thumb, I tend to keep a couple of decimal places more often than not. So 13,725 kilometres. Now to find the time for the journey, the plane travels at 550. You'll notice some of the times in this book are a little bit on the speeds are a little bit on the slow side. We normally find probably 700 or so. That might accommodate a stopover perhaps. So 24 hours and 57 minutes. Now, when we work the arrival time in Jerusalem, we've got to work the standard time difference. Now, Jerusalem is behind Melbourne, so Jerusalem standard time is equal to approximately 35 is UTC plus 2 hours. And the EST is UTC plus 10 hours. So we can say Jerusalem 8 hours behind, or minus 8 hours. So Jerusalem, ETA, it's the 21:15 we left on the Wednesday, plus the 24:57 in the air, take 8. And that's 31 at 12 on the Wednesday. So from that, I take off 24 hours, and that will be 14:12 on the Thursday. Now 2:12 p.m. if in fact the back of the book does list that. Now take time to look at the workings involved there. They're pretty stock standard for these style of questions. Very important that you can get the processes down.